Welcome to EDU Aero Classroom. In this tutorial, we will discuss algebra of limits and direct substitution method of evaluating algebraic limits and factorization method of evaluating algebraic limits. Firstly, we will discuss algebra of limits. Let limit x tends to a fx is equal to L and limit x tends to a gx is equal to M. And also, if L and M exist, then there exists some result. First result is limit x tends to a f plus minus g of x is equal to limit x tends to a fx plus minus limit x tends to a gx, which is equal to L plus minus M. It says that suppose there is a function like this 3x plus 4x square. This is one function. We can break this function into function like this. Limit x tends to a 3x plus limit x tends to a 9x square. This is one result. That is, we can break one function in two functions. Second, if both the function are in multiplication and there exists one common limit. Another function is limit x tends to a f gx is equal to limit x tends to a fx into limit x tends to a gx, which is equal to L. If some function is given like this, suppose x into 4x square. So we can break this one function in two function like this. Limit x tends to a of x into limit x tends to a 4x square. The result of both the function will be same after breaking and before breaking. Third is limit x tends to a f by g of x, which will be equal to limit x tends to a fx upon limit x tends to a g of x, which will be equal to L by M, provided that M should not be equal to 0. This is the condition. Suppose two functions like this, limit x tends to a and x upon 2x. So we can apply separate limits in numerator and denominator. This result is this. Next result is, it is fourth. If limit x tends to a k of fx, where k is some constant, then we can write this like this, taking out constant outside the limit and applying the limit on a function separately, where k is a constant. For example, suppose we have a function like this 4x. So we can write this like this, taking out 4 out of the limit, then x tends to a of x. This result is this thing. Next result is limit x tends to a mod of fx is equal to mod of limit x tends to a fx. That will be equal to mod of L. Next is limit x tends to a fx raised to gx will be equal to L raised to M. Next result says that if limit x tends to a f of x is equal to plus infinity or minus infinity, then limit 1 upon limit x tends to a, fx will be equal to 0 because we know that 1 by infinity is equal to 0. So these are the some result, or we can say the algebra of limits, which will follow while solving the question of limits. Direct substitution method of solving algebraic limits. We apply direct substitution method to a function in which we can directly put the value of the limit in the function. For example, consider a function like this: 3x square plus 4x plus 5. In this function, we can directly put the value of the limit, that is 1, x tends to 1. Putting the value of x as 1, which will be equal to 3 plus 4 plus 5, that will be equal to 7 plus 5, which will be 12. Direct substitution method cannot be applied where we lack some condition or where indeterminate form is made. That is, suppose um, function like this: 3 by x and limit tends to x tends to 0. If we apply the limit directly, then we will get the answer infinity. So direct substitution method is not applied over function where the answer where the limit assume the indeterminate form. Indeterminate form means the form of like this: 0 by 0, infinity by infinity, or 0 into infinity, minus infinity, and so on. These all forms are called indeterminate forms, and direct substitution method is not applied to solve indeterminate form. To solving indeterminate form, we apply some other method which we will discuss later on. So now firstly come back to direct substitution method. Direct substitution method is applied to the function in which we can directly apply the limit, and we will get a fixed real number as the answer of the limit. Suppose consider example as limit x tends to 0 under root of 1 plus x plus under root of 1 minus x divided by 1 plus x. So we can here directly apply the limit. After applying the limit, no indeterminate form is formed, as we can see that if we apply the right limit, we will get under root of 1 plus 0 plus under root of 1 minus 0 divided by 1 plus 0, which is equal to under root of 1 plus under root of 1 plus 1, which is equal to 1 plus 1 plus 1 is equal to 2. So here we get a one finite quantity or a real number. So direct substitution method is applied where we can directly apply the limit and no indeterminate form is formed. Now let's consider another method of solving algebraic limit, that is factorization method. Consider the limit x tends to a, fx over gx. If by substitution method at if we apply here substitution method and we get form 0 by 0, then x minus a is a factor of fx and gx both. So in this case, first we have to factorize fx and gx and cancel out the common factors, and then apply the limit. So factorization method is applied where after applying the limit we get the form 0 by 0, and so in this case firstly we factorize the function fx and gx, then we will cancel out the common factors and then apply the direct substitution method. Let us see one example based on this method. In this question, we have to evaluate the limit x tends to 1 of a function x cube minus 1 over x minus 1. Firstly, we will apply directly the limit. And we can see after applying directly limit, we get 1 cube minus 1 upon 1 minus 1, which is 0 by 0 form. So clearly, x minus 1 is a common factor a of numerator and denominator. So factorizing numerator and denominator, we have limit x tends to 1 x cube minus 1 over x minus 1. As we can see that we can apply the formula of a cube minus b cube in the numerator, which is equal to x minus 1 x square plus 1 plus x divided by x minus 1, because as we know that a cube minus b cube is equal to a minus b in bracket a square plus b square plus ab. So applying this formula over here, we get this term, and as we can see that x minus 1 is common in both numerator and denominator. So this both term will be cancelled out. We will get x limit x tends to 1 x square plus 1 plus x. As we can now use the direct substitution method, we will directly apply the limit over here. We will get 1 square plus 1 plus 1, which will be equal to 1 plus 1 plus 1 is equal to the required answer. So we have seen one example based on factorization method, and which we can clearly see how this can be solved. So we conclude that factorization method is applied where we get the form 0 by 0. In this method, we apply the factorization method when we get 0 by 0 form. So there is a need to apply the factorization method.